This is the principle of the capacitor that you didn't understand in your 4 years of middle school. If the physics teacher had taught this way, your home would now have at least 2 full-price models of your dear. In fact, the structure of a capacitor is very simple. It consists of 2 aluminum plates with an insulator in between. When we connect the circuit, electrons flow from the negative terminal of the battery to the positive terminal. But due to the insulating material in between, they cannot immediately flow through. Therefore, electrons accumulate on the aluminum sheet at the negative terminal, and the aluminum sheet at the positive terminal loses electrons due to the electric field, forming a positive charge. This establishes a potential difference across the capacitor. Then we remove the battery, and as the circuit is disconnected, the flow of electrons also stops. Next, we switch to an LED bulb. As the circuit is connected, due to the presence of a potential difference, the electrons on the negative plate start moving toward the positive, and the current passes through to light up the bulb. This is discharging. At this point, you might think this is just a battery, but their functions are quite different. Let's take a look at how the capacitor works. In this circuit, the capacitor is connected in parallel with the battery and the bulb. When powered on, the capacitor completes charging and energy storage. If the battery voltage suddenly drops, the capacitor will discharge in relay, thereby briefly maintaining stable current. This is like a constantly flowing water pipe. If the valve closes, the flow stops. However, if a storage tank is placed below, even if the valve is temporarily closed, the stored water in the tank can still briefly maintain the flow. Therefore, maintaining stable voltage is one of the main functions of a capacitor. In addition, the charging and discharging speed of a capacitor is much faster than that of a battery. For example, in this setup, battery power can slowly lift a weight with the motor. At this point, we add a capacitor into the circuit, first charging the capacitor with the battery, and then discharging the capacitor to the motor. It can be seen that the motor speed has significantly increased. This is because the capacitor can provide a larger instantaneous current than the battery in a short period, helping the motor achieve greater power output. So capacitors can supply power to devices that require fast charging, like camera flashes. In addition, capacitors also have the characteristic of blocking direct current while allowing alternating current to pass. This means that in direct current circuits, the flow of electrons is interrupted due to the presence of an insulator in between. However, when switched to an alternating current power source, the current direction keeps alternating, so it does not affect the circuit's flow. Therefore, capacitors can effectively remove the direct current component, allowing only the alternating current signal to pass through, which is called coupling capacitance. It is commonly used in audio signal processing, circuit amplifiers, and communication circuits. Did you learn it?